Welcome to another Techniques Auto Center video. We have an electric Mini. It's a 2024 model and it's involving an accident. All this section of the vehicle is damaged. Before we get into the repair, there's a few topics I would like to cover. One is tools, the other is PPE, meaning your personal protective equipment, and resistance between the high volt circuit and the chassis. In other words, leakage, high volts leakage into the chassis. Why I want to go over these topics? Because I know, after watching this video, many of you guys will try your thing, try to do something, try work on a EV vehicle. And I don't want you to do anything that would be detrimental to your health or you get electrocuted. And working on the EV high volt circuit is very serious and you have to follow the safety procedure. As you know, the EV have a 12 volt circuit and it have a high volt circuit which can range from 400 volt going up and sometimes less than 400 volts, but let's say from 400 volt going up 600, 800, depending on the type of EV. So that's a serious amount of voltage and you can get electrocuted. So we don't want to sugarcoat the repair. We want to deal with the reality and do the repair in a safe way. The EV is just being developed at a certain standard, so there's constant change on the process and the way how you perform repairs on the EV, but nevertheless, one of the fundamental things, if we go back old school, is don't allow your body to become a pathway to negative or hurt. And that's the fundamental with the EV high volt system. Start with the tools. Here I have some special EV tools, and this is just a few pieces. We have a lot more tools, but this is just for demonstration purpose. So let's say this is an EV spanner and this is a normal mechanic spanner. This is a 17 millimeter and this is a 24 millimeter. But what's the difference with these two spanners? One is protective. It have a nice thick rubber coat over it. I'm not sure if I'm in the correct angle of the camera, but hopefully. And this one have no protection. This is just the metal. So this spanner or sockets or screwdriver is not correct to work in the high volt circuit. This is the correct protective tool here. And if you're going to work on EV, you need to have these tools. There's no getting around it. Here is the EV tools, and this is the traditional mechanic tools. So these are protected. These are protected for high volt system, and these one are not protected. These are just straight metal general mechanic tools. Working on the EV, you will need both. And one of the issues I found with the EV tools is they can be bulky, meaning the rubber coating on the tool make it bulky. So certain areas, it is a challenge to work with it in that tight space. So You have to make a little common sense prevail when you're working on the, when you're using the EV tools or the regular tools. Important, you have to make sure the system is powered down correctly, the high volt system is powered down correctly, and that's where we want to talk about the PPE. PPE means your personal protective equipment. So, working in the high volt circuit, you would definitely need these rubber gloves, and these particular gloves is rated up to 1500 volt. You also need these leather gloves. These are special electric leather gloves, which you would put on your rubber gloves first and put this leather gloves over the rubber gloves. And one of the things is that the rubber glove is easy to punch or cut. These leather gloves will protect these and also help with the resistance with the high volts circuit. The next thing I have here is a multimeter, and with this multimeter it can track many different areas of the EV. It's a special EV multimeter, and when you're checking for high volt leakage, you want to use the correct tool. Over here I have a regular tennis rubber sneakers. So, in the traditional mechanic work, you need to have your steel toe shoe and so on, but working in the high volt system, you can't wear that steel toe shoe, and you need to have a proper high volt boot. But if, we always like to keep the things simple and cost effective. So, if you don't have a proper high volt working boot, then the next simple thing is just a regular tennis rubber shoes. It's perfect in protecting in high volt system. The next thing I want to go over, or the next topic going to be the formula. What is a safe amount of current that can leak from the high volt system to the chassis? Or what is a safe amount of leakage that won't be detrimental to your health, cause electrocution, or cause death? And as I say, we have to speak straight, no sugarcoat. You can be electrocuted working on the electric vehicle. So we have to avoid that. And there's another topic too. Whenever working on the EV, you want to make sure that someone else is inside the shop who is trained to provide first aid. Meaning, even though you want to follow all the safety procedure, or you follow all the safety procedure, something can happen, something can go wrong. And if something do go wrong, where somebody get caught up in the high volt system, you need a trained person to remove them from the high volt system. And don't cause that second person to be electrocuted also. And you need to be able to perform CPR and basic first aid. So it's important to have somebody in the shop who is trained, qualified first aid person. The next thing I want to cover is you have to power down the high volt system correctly. Because if you don't touch the vehicle. Once the high volt system is powered down, all a EV would have a disconnect. And a disconnect where you can put a padlock to lock it, and you lock away the key. The person who trained with the high volt system, certified with the high volt system, would have the key. So that provides a layer of safety where another technician don't accidentally go turn on the high volt system. But with the newer EVs, you don't have that lock. So you have more like a breaker or a fuse or that you would pull out from the connector with the high volt wire connector. And once you pull that out, then it shut down the battery or the controller, different high volt part in the system. So important the system is powered down correctly. With this formula here, again, I'm showing it to you because I don't want you try working on an EV in an unsafe way, and you have to know how to calculate the resistance between the high volt circuit and the low volt circuit. And you have to be able to work it out on different type of voltage. So it's important for you to understand this formula. So let's get into the formula. And I haven't used a blackboard. Back in the day, we call it blackboard. Let's call this one a whiteboard. I've written on one of them for 30 years, so I'll give it a go, but don't smile if it's not beautiful. So let's get into the formula. So the first thing I want to say is it takes a tiny amount of amperage to cause death. So what is a safe amount of leakage or a safe amount of current that can be leaking from the high volt system into the chassis? That's what we want to work out. What's the safe amount of leakage that won't cause death? And I keep emphasizing that because it is that serious. Let's say we have a 400 volt system and I'm trying to figure out how much current flowing through the system. That's why we have this formula here. So for every 500 ohms, there's 1 volt flowing through the system. Say we have 500 ohms of let's say we have 500 ohms of resistance over 1 volt. 500 ohms of resistance over 1 volt. Okay, let's say I have a 400 volt system times 500 ohms over 1 volt equal to 200, permission to backtrack, Let's say I'm working on a 400 volt system times 500 ohms over 1 volt equal 200,000 ohms. This is the minimum resistance you need between the high volt circuit and the chassis. 200,000 ohms. How does this translate into a safe amount of current that can be leaked in the chassis? Let's say I equal volt over resistance. I equal volt over resistance. So let's put some numbers to this formula. So what this means is I equal 400 volt over 200,000 ohms. I equal 400 volt over 200 ohms. So this means 0.002 amp or 2 milliamp. Now we get to this abbreviation here, FMVSS 305. This means Federal Motor Vehicle Safety Standard 305. So according to this standard, the maximum amount of leakage from the high volt system to the chassis is 4 milliamp. So 4 milliamp is the maximum amount of leakage that can go from the high volt system to the chassis. So that's a really tiny amount of volts. The maximum amount of volt that can leak into the chassis is 4 milliamp. So that's why this standard exists. The minimum amount of ohms is 500 ohms per 1 volt flowing through the system. Remember, this formula, you have to get it right, especially when you're working on an accident EV. You want to make sure there's no high volt leakage, and even if there's some leakage, it's a safe amount that won't cause death, where you can work around to, de-energize the system. But most important, if you don't understand this formula, again, don't touch the EV. And I'll just put a few clips in the video about different safety issues or procedure you need to be mindful of. So once those clips finish, then we'll just jump into the repair. I'm going to do a separate video for current flow, and I'll do another video for how you check the leakage in the high volt system. I'll do an in-depth video on it. But let's stop here for now with this formula, and let's get into the repair. This is a 2024 Mini Cooper electric. It's my first time working on this vehicle, but let me say a little patois. We're not afraid of nothing. Meaning, every new technology that come out, we always make sure we understand it, learn about it, and repair it. And as far as I can go back, whether you're talking about fuel injection system, name it, ignition system, all different type of, is always something new coming out on a motor vehicle. And we never be afraid. I talked to a few guys, and one of the understanding I'm getting is that a lot of the traditional mechanics is afraid to touch an EV. So one of what you find is outside of the dealership, there's very little mechanics that work on EV. And we want to change that. We can't be afraid of modern technology. We just do what is necessary to improve your knowledge so you can work. And I'm sure this video will go a long way in helping you improve your knowledge. So let's jump into the repair. And I can't show every single detail because it's a short video, and some things we have to keep a little bit of the recipe for ourselves, but I will show you a lot of stuff in the video, and I'm sure you will learn some stuff from it. So let's jump in. Now I have to take off these regular mechanic gloves. These are just some normal latex rubber gloves, but these are no good for the high volt circuit in the electric car. Then over the rubber gloves, I'll put these leather gloves on. These are actually special leather gloves, not just any leather gloves. Okay, so this is what you got to have this is what you have to use when you're going to work in the high volt circuit for the electric car. Okay, the high volt battery has been disconnected. Let me correct. The high volt battery has been safely disconnected. Now I'm going to start at this point of the repair, I will start to remove some of the wire loom connectors so we can start clear the engine, the electric engine.